Okay, trying again. Welcome to Wednesday of week 5. There were some gradebook errors in week 5 homework part A. 2 of the problems were recording correct answers as wrong. So I wanted to go over them briefly, mostly because of that, but also because people wanted recordings of some of these from the study sessions. And as far as I know, that didn't happen yesterday. So the number 5, what's the mean of the cost of the textbooks? We want to add them up, find the sum, and then divide by how many. The sum we could get by adding them all up. We have 50 8 times, 50 plus 50 plus 50 plus 50, 8 different 50s. That would just be annoying. 34 100s, we'd be here all day adding these up. Our thumbs would get tired of calculator pushing. So it's easier to multiply each row. We have 8 50s, and that's 400 so far. And then we have a bunch of hundreds and so on. So 50 times 8 is $400 contributed to the sum from the 50s. 100 times 4 is $3,400 contributed to the sum from the hundreds, and so on. And when we're done, we add them all up, and we find that the sum is 38,000. The how many, we just add up the frequencies. There's 200 textbooks in this sample. Then we can do our sum divided by how many and get our mean. Questions about that one? Okay, now the two that the gradebook JavaScript is doing wrong. So if you turned these in and I said you got them wrong, maybe you got them right. Let's talk about it. For the median, again, we could list everything out. We could make a list of 50, 50, and all the way until we finally get to the last of our 350s and try and find the middle value of this giant list. But that would be the wrong way to do this kind of thing. We would have to list out all 200 numbers. We would be here all day. So knowing that there's 200, we just have to find where the middle one is. The median is where is the 100th one. So as we made our list, the first 8 things would be 50. We have 8 so far. Then as we continue to the right on our list, the next 34 would be 100. So we have 42 things so far, adding up those. Then the next bunch of things would be 150s. So adding those up, we have 98 things so far. So the 100th one will land in the middle of this clump of $200, where we're listing 200, 200, 200, 200 again and again and again. So if you thought that 200 was the median, then you were correct. If the grade book said no, then I apologize for wasting time and causing confusion. Questions on that one? Okay, the last one, the standard deviation. Deviation, without the word standard in front of it, is how far away these numbers are from the mean, which was 190. So anything that was a 50 is $140 away from the mean. 190 minus 50 is 140. Anything that was 100 was $90 away from the mean. The ones that were 150 were pretty close. They were only $40 away from the mean. The ones that were 200 were even closer. They're only 10 bucks off, and so on. So we won't learn until next week how to actually calculate the standard deviation, but which of these multiple choice answers could be the standard deviation? Well, $5 is way too small, right? They're all more than $5 away. So that can't be a typical value for how far they are from the mean. 160, that's the most they are. So that's not going to be a typical distance from the mean, because that's only counting the very farthest ones. Everything is going to be closer than that otherwise. So a typical distance is going to be smaller than the maximum. 200 is even worse. All of these are less than 200. 200 doesn't represent how far they are from 190 at all. So the only answer that could possibly be true is 78, which again, the gradebook JavaScript was marking as wrong when it should be correct. I am sorry if I wasted your time and made you pull your hair out, but 78 is the only one that could be representative. And that makes somewhat of a good amount of sense. A lot of these values are this area, and then a few of them are bigger. So how far kind of an overall distance from the mean it is, with things that there's lots of, counting more than things that there's few of. So 78 seems somewhat reasonable, and we'll actually calculate it next week. Okay, questions on any of those old homework problems?
Where did you get the deviation from? Or the deviation from 140 from what, 190? I just didn't understand the deviation at all.
If you're talking to us, Julie, you're really quiet. I can't hear you.
I guess my volume was low. So on the deviation from, you're getting that from the 190?
Right. We found earlier that the average, the mean, was 190. So as math jargon, the deviation is how much they deviate from 190, how far away this data point is from average.
Okay. And is that always from the mean, or
That's what the word deviation means.
it's always from the mean? Okay.
Mhm.
Thank you.
You're welcome. Okay, so today is kind of a strange day that I want to go over the homework, week 5 homework part B, but I'm going to wait a moment to do that. We should finally do a quiz, but I want to wait towards the end of class to do that. I have received a heads up from someone that people want me to go over the syllabus grading again and talk about that because it's confusing and it's been a few weeks since we talked about it. So I want to do that. Mostly we've done all of the talking about week 5 stuff and it didn't go great. And partly that's because we were trying to go from the textbook for a lot of this, and I was disappointed with how it was organized. There wasn't really much order, rhyme, or reason to it. And so I'm going to ask you to help me plan how to do things better next term. This is our describing data spreadsheet. You've only seen that page before. It is the one that has a link to it at the top of week 4 and at the top of week 5. And when I actually get week 6 ready, it will be at the top of week 6 also. But I put a second page on it called Future Planning. And I've made up some images on the right and pictures and so on. And I want to get your feedback of next term. How could this be taught better? What's a better organization for it? And as we go through this, then we'll review everything. So it will be both a way to make today an organized review day and a way for you, as the students learning this the first time who were just subjected to all of it, to give me feedback as an instructor of how to plan this better. So my idea is that first we'll talk about this, do our review. Then we'll talk about this assignment. after doing the review, this will seem like it will make a lot more sense. And then we'll talk about the syllabus stuff. And then at the end, we'll have a quiz based on old homework problems from week 4 and maybe week 5A if people feel ready. But maybe we should just do week 4 because some of these were broken, as we found out. Does that sound like an okay game plan for today?
Yes.
Yes, okay. As a little bit of pedagogical history. So once again, I'm used to teaching Math 25. And when we talked about retirement, then that didn't have too much differences. That simple interest, compound interest, building up annuity, all of that we had already in Math 25. I just had to add some things at the end about monthly annuity and payout annuities. That was new in 105 and not in Math 25. So it didn't bother my flow much. I was still organized. I was just doing extra stuff at the end because you know some algebra. As a tangent, we never did the how much to save. We're saving this on purpose for review week before the final exam. There's a little bit of a good excuse to review these formulas that will seem very rusty in your brain. So when I inherited Math 105 stuff to teach, there were some great things like these pictures in Paula's worksheet. And then the textbook has its own things, and smashing it all together to be convenient for you, I knew would be tricky. I just didn't realize it would be quite so tricky. So if I was teaching this again, what would I do? I think I would start with a theme of picturing data. And the very first thing I would show people would be this picture of the kids with pets. I would take this and put it on the web page nicely. And I would say, look, kids with pets, right? It's how we would start personal finance decisions or something like that. And I would talk about this picture with kids with pets. I'm just going to shrink it down so we know what we're talking about. And I'm going to say, this is a frequency table about which kinds of pets they like. 6 of them like cats, 3 of them like fish, 5 of them like birds, and so on. So this is easier to look at than the picture of the kids jumping around with the words all over the place. That's why we draw frequency tables. And then I would say, oh, we could take this frequency table and if I just rotate it on its side, then I could say, instead of the numbers 6 and 3 and so on, we can draw our bars. And we could say there's lots of cats, and there's half as many fish, and there's almost as many birds, and there's not very many horses, and dogs are in the middle, and there's only 1 unicorn. So we can make a bar chart out of a frequency table by just picturing these as how tall the bars are. Something like that. Then we would talk about how to draw it, since I just sort of did it quickly. Did we talk enough this term about how to actually draw bar charts?
I think so.
I agree.
Yeah, I think that there's enough talk about it. And I like your concept of getting rid of the picture and just sticking with data in like 2 forms, as opposed to moving from the picture to this table. It's like moving from this table and then turning it sideways is definitely easier to understand what you're doing with data.
Okay, so I should make a note to myself here to really do 3 different steps. And not that directly. Don't go just from the picture to the chart. Is that okay code for myself? Do 2 steps. Okay, something like that. Then, so that was that. And then we talked about the Pareto charts, how you can say, well, this favorite pet chart is nice, but sometimes you want to sort it from biggest to smallest. If you were just kind of saying to your class, we're going to get 2 pets for the classroom. Here's why we're getting a cat and a bird. That's not going to work well, by the way. Anyway, then sorting them sometimes helps you present your data, because part of our theme is being persuasive, not just using the math. Then we should talk very much more intentionally, and I think earlier, about counting the frequency versus relative frequency. So that's this chart here, that when we just counted it, that was all fine and dandy. The relative frequency is what percent of the whole is each of these categories. And it might be because I want to label my bars and do something that looks like this. Where I am. So put a label that this one is 29%. This one is 24%. Right? Sometimes that's the right thing to do at your business meeting. Or maybe you want these relative frequencies for some other purpose. Maybe you're wondering that you didn't ask what's your favorite pet, but what pets do you actually have? And then you could ask what portion of 300 students, right? If there are 300 students, how many would vote for cat? Right now, there were 21 students. But if there were 300, if we broadened this up to the whole elementary school, how many would vote for cat? Well, then we could say cat is 29%. So it would be 0.29 times 300, which is going to be awfully close to 90. Does it go down? 87, it does. So sometimes the relative frequency is helpful to you because you're going to use the data in some way that broadens the sample size. One other way that relative frequency is useful was the making a pie chart. So that was using relative frequency in a pie chart. So with a pie chart, then each wedge is part of a circle. Each wedge is part of 360 degrees. So cat is 29%. And whatever that was, 103. So then I take my protractor, measure this angle, and this is supposed to be 103 degrees if I was drawing it with a pencil and paper on a protractor. We also had the pie chart by times 60 and by cut and paste. We also talked about how we could take the bars, physically cut them apart and draw a pie chart that way, more as an art project than a protractor project. Okay, questions about any of this so far? Things you would teach differently, things that should have more examples or less examples than other things, which part was confusing to you as it went by, but now you got it, which part is still confusing to you. Let's do another example problem.
David, I think the most confusing aspects of all of this for me is just understanding what presentation, what graph would be the best one to use to present certain data. And I get kind of lost in the options as opposed to you saying, well, if you want to present how many people like this color, then you would want to do a pie graph, or you would say what percentage of dogs like kibble as opposed to raw dog food or something like that. It's like trying to understand what graph to apply to what data source. Does that make sense?
It does. It's also more of a kind of personal choice than
Okay,
anything else.
then it should.
I was surprised when in the forum for this week, we asked what kind of graph you like for this kind of data for the surveys you were making for each other.
Mm-hmm.
And almost everyone likes bar charts more than pie charts. They don't think anyone voted for pie charts for any of the surveys you made for each other. And in some ways, that's not surprising. Right? This sort of is a clear comparison.
Mm-hmm.
We're not used to thinking about angles as much as we are heights.
Right.
And so part of it is sort of like, why are pie charts popular? There aren't many examples of great pie charts that have changed the world.
You know, one really good use of a pie chart is when you're running a business and you're trying to understand the expenses and what percentage. So if you have a group of expenses, out of all of the expenses, what does your company have the most of? So I know that in working with my clients, they really like pie charts as opposed to bar graphs, just as an example.
That's a good example. I think part of it is just historically, pie charts used to be harder to draw before our spreadsheets for us. So
Sure.
your presentation looked fancier if you drew a pie chart than a bar chart, because you just needed, a ruler to make a bar chart. Pie charts are kind of most meaningful when things are very different. So here's one of the pie charts that maybe you've never seen, but caused a giant stir in the economics world. Some blogger, Mark Beal, August 2018, said, there's this book, A Random Walk Down Wall Street, that says it's really hard to beat the market. Don't buy individual stocks. Just buy an exchange traded fund that has very little annual cost called the expense ratio, that has a little bit of all of the S&P 500, and hold on to it until you retire. As you're getting close to retirement age, then sell it, because you don't want the market to go down right when you need to retire. We've talked about all these things before, but why would anyone as a normal investor want to buy an individual stock? And that's good advice. Kind of the only other thing you need to know is beware of taxes, and move things into bonds and cash as you get older, so not as much of your money is volatile, right? All those basic things we've talked about. But Mark Beal wrote this blog post that said, don't imagine that when you buy an S&P 500 exchange traded fund, you're getting equal shares of 500 companies. That the bigger the company is, the more of the exchange traded fund will be represented. So he made this pie chart, and you can see that most of what you're buying are Apple, Amazon, Google, Microsoft, and Facebook, and all the other 495 companies are these tiny little slivers of the pie chart. We talked probably too much last time about what short selling is. Why would anyone bet against a stock? So this is one example. If you really wanted sort of an even share of the 500 biggest companies, you could buy what the market is doing and then buy some negative shares effectively of Apple, Amazon, Alphabet, Microsoft, and Facebook to decrease how much of them you had. Even out your exposure to these 500 companies. But this works because of the contrast between the big pie slices and the little one. If we tried to make this into a bar chart, we couldn't even see these little bars. They would be too tiny, right? But yeah, there aren't too many cases. I'll put this in chat just in case you care or have relatives that would care. But there aren't too many cases where the pie chart is the best way. And usually it's kind of whatever your audience you're presenting the data to would want more. So
that helps. That definitely helps to alleviate some of this stress that I was putting on myself to try to figure out the best graph for said situation. So it's really more about the audience.
Okay. Anything else about all the stuff we've done so far before we move on? We haven't done a ton of examples of using relative frequency. Should we do more of those?
Sure.
Yes.
Yes, okay. So let me grab another chart. This is similar to the homework, but not exactly. We'll change the setting for this, but it's nice to have the chart already for us. Let's imagine that you are just running a movie night, and this is the kinds of movies that your audience likes most. So movie night, and this is something that's happening every week. So each Saturday night. So we have 52 weeks to plan. So the question is, how many movies of each of these genres that you know your target audience likes should you have in your annual plan? How many dramas, how many actions, so on. So you took a survey, only 22 people answered the survey, but you can trust for some reason that they are representative of your whole target audience. So we want a new section that is out of 52, right? what am I calling it over here? A portion of 52. So I'm going to take these relative frequencies. Anyone need a review on how we got them?
Yeah.
We took the counted frequency and divided by the total for each of these. 7 divided by 22 is 0.32. And there's probably rounding in there somewhere that the spreadsheet did. So that's how we got each of these. 5 divided by 22 was about 23%, and so on. So we take each of those relative frequencies, multiply it by our new total, and see what we get. And of course, when we multiply, I'm not going to put 32 in my calculator. I'm going to do 0.32 because that's what my calculator likes. So 16.64, I'll need to round that and say about 17. .23 times 52, 11.96, so that will turn into 12. .14. Oops, I did the wrong thing just then. I'm getting lost. So 0.18 times 52. Oh, it was. So 0.14 times 52. There we go, 7. And then when we're done, in this particular case, to be realistic, we need to add these up. Did we get back to 52? Yes, we did. Sometimes the rounding that happens above makes this a 51 or a 53 when we add them back up. And then we'd have to say, we're not quite ready. So for 17 weeks, we'll do drama. For 12 weeks, we'll do action, and so on. Ta-da! Was that enough of more examples? Should we do more?
Let's go ahead and just do one more, just to really.
Yeah,
get
can we
into it.
do one more?
Yeah, thank you.
I don't have a nice table made up, so let's just do one. What are we counting instead of favorite genre?
Car types,
Card.
car models.
So what do we have? Like subcompact, compact,
Yeah, minivan, station wagon,
bigger?
SUV.
Okay, something like. I suppose we should have a total. See. Okay, I'm just gonna put new numbers in, 11, 15, 24, 6, 7, something like that. So again, for each of these, I take the counted frequency, divide it by the total. If you know about spreadsheets, I have to put a $sign in. So okay, we have some data. So what's our story? What's the word problem? We're trying to figure out what to stock in a car dealership. We're wondering what's in the parking lot at the mall on Black Friday.
How about favorite or well, favorite's fine. Favorite cars in a parking lot at a elementary school.
Okay,
Well, I was gonna say the
So-
most recent holiday coming up, President's Day, they always do vehicle sales.
They do. They do.
okay, so
Either way, I don't care.
okay, so parking lot predictions. So someone sent out a survey, maybe they're building a new shopping center or something, and 63 people answered the survey saying what kind of car they have. And your job is to plan the parking lot. And the parking lot's actually for how many cars? More than 63. Say, what, 200, 300? What's a good big number for a nice parking?
Let's go with 400.
400. Okay, so 400 cars are going to be there. And we're wondering how many of each type of car we think we'll need to plan. Because if there's a lot of SUVs, we might need bigger spaces. If there's a lot of subcompacts, we might want some rows, especially for them that aren't quite as wide to save space. You know, who knows what we're going to do. I have no idea what the actual legal requirements of parking lot planning are. I am only a math teacher. But the point is that 11 divided by 63 was 17%. So what is 17% of 400? For each of these, we're going to do a multiply it by 400. And to save time, I'm not going to actually do that in my calculator because you've watched me hit calculator buttons enough today. I'm going to say portion of 400 and just ask my calculator to say it will be F102 times 400. So we get about 70, 96. $152 and 38. And 44. Did those actually add up to 400? Whoops, 400, that's not right. 38 and 44. I said 44 out loud, I just didn't write it. Okay, so 70 plus 96 plus 92 plus 38. Yep, it adds up to 44. So sometimes it doesn't. If everything just happens to round down a little bit or whatever, you might need to fudge your number. Questions on that one? Remember for these that 17% of 400 equals 0.17 times 400. That's what's happening in these spots, right? The times 400, we're really thinking of 100. Whoops, I texted a link only to one person. Okay, there's that crazy chart if you cared. Okay, that's helpful. See another example.
I think I'm good for now. Thank you.
So moving on, then we would talk about, after all of that stuff, for picturing data, what we did with typicality. That typical kind of means things, what's most representative, what is most common, or add them up and divide by how many. And in a friendly data set, then those all mean the same number, right? They all sort of measure the same thing, and it's pretty clear what's typical. But sometimes those don't, or they make questions. So we had those pattern block things. What was most typical in a situation? And just get your brain thinking that it's not always an easy or even sensible question to ask. Then there was the second group of pattern blocks, where we put in these big ones to cut it even more often. There's a tension here that I'm not quite sure, teacher, that part of what I want to teach you is that it's easy to ask absurd questions with data. If someone says, what the average pet that this, then that's not a good question, right? If I ask that to somebody, the correct response is to say, well, there's a most popular pet, but not by a lot. Using the technical math jargon, there's a mode, a most common number, but I can't add them up and divide by how many, because that doesn't really do anything. They're different kinds of animals, right? Unless we're turning them all into dinosaur food, they're just too different. It doesn't really make sense to say what an average is. And if that's not your first response when someone says, what's the average favorite animal? If instead you start second guessing yourself and saying, my authority figure, my teacher or this book or something must be asking me a meaningful question, I must be confused. No, you're not confused. They're just asking you a stupid question. So I want to introduce that, but not confuse people while I'm doing it. And I'm not quite sure how best to do that. So that was the intention with these blocks, to show you that just because we can ask the question doesn't mean it's a good question. It's really easy to ask absurd questions with data sets. When I make the pattern blocks, now we're looking over here into frequency tables, it doesn't really help, right? This frequency table on the screen isn't any more clear than that picture. It's even less clear because it's sort of true that two blue blocks is a green block. I'm sorry, two green blocks is a blue block, and that doesn't show up at all here. And this frequency table is less helpful than that picture, because it's sort of true that 2 green is a blue, or 3 green is a red, or 6 green is a white, and you don't see that at all in the frequency table. If I made it a bar graph, that's not any better. It might help you say that there's not really enough reds to care about, but you could see that just as well from looking at the picture. It might be say, oh, I'm the kind of person that picks blue because there's the most of them, but you could see that just as well from the picture as from the bar chart. So this doesn't really help. And that's something that I want to point out, but I'm also not great at knowing how to point out that you don't always make charts for things. Charts aren't always helpful. And sometimes there's data sets where you make a chart on purpose because you're in advertising or a politician or something, and you're trying to make something less clear than it is. Look, most things are blue, or simplify something more than it really should be simplified.
David, I think because confidence is such an issue in math, and people, many people lack, myself included, that when lack confidence in their math skills. And so when a question is asked, you automatically think there should be a decent answer. And then you feel like you might be an idiot if you don't have a decent answer. So then it's just this domino effect. And so I feel like if you were to explain to people first that the data that you're presenting and the question that you're asking is not, you can't answer the question with the data that you're presenting first, and then people can kind of discuss why that is not possible. I think that might help, as opposed to asking a question that can't be answered, because people don't generally trust their own judgment.
Right. So unfortunately, no one who planned Math 105 before me gave me a good list of those types of questions. I always have to sort of pay attention as I encounter them, which is unfortunately frequent when everyone is talking about pandemic numbers, right? Cases, mask wearing, and so on. We are daily, if you watch the news, I hope you're not bombarded by meaningless numbers. This state versus that state, this country versus that country. Let's make comparisons when we have no right to make comparisons. People are trying to force numbers to make answers because, I can take my calculator and smash numbers together and get another number, but that doesn't mean it means anything just because I do that. So getting some timeless examples of this is certainly on my to-do list. The famous one, of course, is that the average family has 2.4 children or whatever it is. Right? Okay, then we could talk about mean and median and mode. We've done that a little bit already. Defining the mean from the frequency table. That's what we started class with. I don't want to list out all 200 values in a long row and add them all up on my calculator. I have better things to do with my life. I'm going to do a multiplying trick to make that efficient. And for the median, I don't want to list out all 200 values so I can pick the center one in the list. I have better things to do with my life. So I'm just going to see when number 100 happens if I was to make a list. Do we need more examples of either of those, by the way, as long as we're talking about them? I see some nods, no one is saying this. Okay. Then we talked about histograms. That hopefully went well, because that's something that I'm used to from Math 25 and had nicely prepared. The histogram is the bar where each bar counts a different category of things. I did look things up, and officially the bins should be sorted numbers. It's not fair to call this a histogram because they're not numbers along the horizontal axis, they're labels, they're a category. So, okay, I can change my thing and make it match the rest of official definitions there. But we talked about how when you make a histogram, okay, thank you, in chat, then you often don't have every score have its own bin. And how you group them matters. This is the same data set, but grouped with more things in each bin, fewer bins overall, and the shape looks very different from one to the other. And that sometimes this happens on purpose, and sometimes this happens accidentally, because if you have everything happen on a computer, it will make a nice chart, even if you don't pay attention to it. And an important thing with histogram is how it's clumped. And I need to take Paula's nice chart that has these pictures. That there's a symmetric, what's called a unimodal, one mode, one sort of most common. I don't like the word unimodal because you could just have one most common thing, but the others aren't similar to it. But it's a little bit different than mode, like mean, median, and mode. But I don't get to change the jargon. So a bell curve, you could have bimodal, a bunch at the bottom and a bunch at the top. Or multimodal, you have several peaks. You can skew things to the left or skew things to the right. If the test was too easy, almost everyone did well and it was skewed to the left. The test was too hard, almost everyone had trouble. Very few people did well, it's skewed to the right. Or you could have uniform data. There really isn't a most common. It just sort of bounces around all over the place. So we did that a little bit. My pictures represented the unimodal, the bimodal, the uniform, and then an important case where things are just sort of running away from the average. Everything is very extreme. And we talked about how standard deviation lets us describe this other than just the fact that this C has a good average. D doesn't really have anything typical. And for A and B, you could find an average right in the middle, but it doesn't represent any of these data sets. So that kind of stuff. We should actually make a histogram in real time in class. And what I do when we're all sitting in the same room is I pass out a whole bunch of six-sided dice, and everyone rolls pairs of dice and adds them together, and then we combine all of our data. So that's something that I will ask us to do as best we can remotely on Monday. So don't go out shopping if you don't own any six-sided dice. It's not that important. But if you have some dice around your house somewhere from some board game or something, then have 2 dice with you when we meet on Monday. And we'll all spend 2 minutes rolling dice and adding up the sum of 2 dice. And then we'll make a collection of all of the sums we got. And we will see that 7 will be the most common, and 2s and 12s will be a lot less common, and so on. And we'll talk about, use that as our introduction to standard deviation and actually calculating. And at that point, that's when we should talk about the deviation from the mean. Because on the histogram, you can really see it, that this histogram has a mean, right, some average value, and how much is each data piece far from the mean. It's almost like the deviation is a bar chart on a bar chart. Right? I could draw a little bar saying how far from the middle is each data piece. And we have to keep in mind that each block on this bar chart is a data piece. A student scored 60% on this test. Another student scored 60% on this test. A third, and so on. So we'll talk about deviation and standard deviation Monday using histograms. By the way, does this picture I just drew help clarify what we did on this slide?
Yeah, I think it'd be nice to see them side by side.
Okay, let's just do that old data again. We can do a little bit of Mondays earlier. So I'm going to take this chart and paste it twice. I'm going to make it once small just to kind of archive it. And another time, I'm going to turn it sideways. No, actually, I just want part of it, don't I? All I want is that much. I still don't know if you see what I do when I highlight how much of something to cut and paste. Okay. Can I stretch it? There we go. So if I'm trying to draw my nice histogram, then I need an arrow there, do I? We have 50, 100, 150, 200, 250, 300, and 350. The highest is 56. So I'm just going to say 60 because I do math with 60 a lot better than 56. So 30 can be halfway. That'll make this 45 and this 15. No one is grading me on my artwork. So 8 is going to be a little more than halfway to 15. 34 is going to be about this time. 56 is almost to the top. 200 is 40 times. 250 is 34 times. 300 is 10 times. And 350 is 18 times. So something more or less like that. Pardon my sloppy artwork. Everyone okay with my histogram? And we had found in an earlier homework problem that the mean was 190. So I can take my picture and draw that at 190. So if 200 is here, 190 is going to be between the 150s and the 200s, right? So that's my mean. So the 150s were off by 40. $150 compared to 190. The 200s were off by only 10. Let me redraw that then so it looks better. I've actually done this in a very long time. Okay, so these are off by 10. These were off by 40. The 250s are off by 60. The 300s are off by 210. The 350s, they're off by 260. The 100s are off by 90. And the 50s are off by 140. And if I drew this nice, it would actually look like the 140 difference is more than the 90, which is more than twice as much as the 40, and this, and so on. You could see it could be nicer if I was a better artist. So the whole issue of what is the standard deviation is sort of how far away from the middle are most things. And again, that's not always a useful question. Was that worth seeing? Was that a good way to draw it?
To help me understand it better.
We, yeah, we'll talk about that more next time. Then something that was mixed in too much, I think we should keep it separate, is this idea of the multivariate data. What we did with the homework here, where we're mixing two different questions. There's two different variables, thus multivariate. Are we homeschooling or not? And how much are you exercising? Or as another example, what's your favorite hobby? And what is your major? So you can make charts like that. Right? Here's a frequency table. But they're a little more obscure because things are broken up too much. And part of it is the part and the whole are often hidden. We had to talk about how in problems 9 and 10, they were purposefully confusing. And someone encouraged me to add a little bit of text to the bottom here. Stay alert. The wording is legitimate but confusing. We know that percentages are thinking part divided by whole. Carefully consider what numbers are part and whole for each problem. Sometimes it is not directly stated, but only implied. Actually, let me unpaste that and put all three in. So when we say what percentage were homeschoolers, then that's homeschoolers as a part of what?
Just as a part of the total of all the students.
Yeah, homeschoolers as a part of total surveyed total students. What percentage were homeschoolers who were getting enough exercise? Then you had to look at the ones that were both homeschooling and getting enough exercise, and that's your part. And the total was all of them that were homeschooling. If we wanted to be clear, we would have reworded number 8, what percentage of those surveyed were homeschoolers. That would be clear. We're putting both the part and the whole in it that way. But it wasn't wrong before. It was just potentially confusing. But that's what makes this type of data more confusing. Other than that, it's just counting and percents and parts divided by whole. You know all that math. There's a little bit of jargon we haven't talked about. That kind of table we just saw is called a contingency table. Certain things are contingent on others. If you are a schooler that is getting enough exercise, that's contingent on you being a homeschooler. And there are jargon about a complementary outcome that's different than a compliment. You look nice today. Complementary in math with an E instead of an I is things that are either for that, but not both. So the outcome in the table of I'm a homeschooler or I'm not, you weren't allowed to say sometimes and sometimes I'm not. On Tuesdays I am, otherwise I'm not. You have to pick one or the other. Are you getting enough exercise? You have a category. You can't be halfway in between two categories. And not all surveys are like that. You could have a survey of what's your favorite genre of movie where you're allowed to say, oh, I like suspenseful romances, not just suspense or romances. And then the other jargon to talk about is simple versus compound outcomes. A simple outcome is once you've done your survey, just one thing. Yes, I'm getting enough exercise. A compound outcome is when you combine rows or columns. So if you said, how many people are homeschooling and getting at least a little exercise, then I would have to add the 10 and the 12. All I am doing is outlawing the not at all. And I'm not sure exactly how important it is to point out that bit of jargon. I think if I said how many homeschoolers were getting at least a little exercise, you could all know to add the 10 and the 2 and get 12 without knowing the jargon of a compound outcome versus a simple outcome. I don't want to make you think you are ignorant and need teaching when you can do it just fine. Just because someone else made up jargon doesn't mean that you are deficient in your math skill. So I'm a little hesitant as to how to approach that. But I also want you to know the jargon. So if you have a coworker that says, let's work out some compound outcomes, then you can do that.
I like jargon. Jargon helps clarify things for me.
Okay.
Just saying. I think it's important to teach it too. And especially like you're saying, if you're in a work situation and somebody whips out with, you know, this is a simple versus a compound survey and you know what they're talking about, it's really helpful. You know, even if you don't exactly remember what it was, you've heard it somewhere and it makes you feel better.
Mhm. Okay, am I forgetting anything? So we've gone through my whole new table of contents as proposed for in future terms. We've used it to review concepts. We've skipped over what's happening next week on purpose. Is there anything that you've been struggling with in the homework that hasn't happened yet today? This should have been a complete review from beginning to end of the describing data topic if I did a good job.
If I have a quick question on part B of this week's homework, it goes back to kind of the jargon.
Okay,
So 9 and 10 are pretty much asking the same question then, or
not quite. 9 is saying that what percent were homeschoolers who are getting enough exercise? So first, let me actually move this so I can draw on it. That's not going to work. One moment. Okay, what is the part in 9?
so it would just be the 2, right?
Yeah.
Well,
Homeschoolers who are getting enough exercise is the 2. And then what's the whole?
And that's why I got confused because I thought it would be the 70 because I thought that was homeschooling and getting enough exercise, and then 10 would be just out of how
For here, the total is 70.
okay, so I was okay.
And then for the second one, what percentage of schoolers were getting enough exercise? Then it's still 2.
Out of 28.
We're only talking about out of the homeschoolers. So it's going to be 2 divided by 28.
Okay. All right. I see that clears it up. That's what I thought. I got confused. All right. Thank you.
Again, if it doesn't tell you what the total is, then the implication is of the total surveyed. Okay, glad you asked that.
So I have a question. So for part B,
Mhm.
on number 1, what are we doing with that? A percent?
Okay, let's go over that. That is the next thing to do. I just asked someone in chat who had to leave early what they wanted, but too bad they don't get to pick. We should do it. I'm going to take this, and copy it, and see if I can paste it into a Word doc. I can. Okay. Now I'm going to switch how I'm sharing my screen and share. So if someone else has graciously shared their attempts at answering this, and we're going to talk about them and see what I actually was trying to ask and what good answers might be. So you are trying to find examples from life of these 10 things. So the first is a percentage that is part of a whole. And that's pretty easy. Anytime we have an English sentence with the word percent of, then there's some implied whole, just like we went over with of the whole people surveyed. So there's 50% of my cake left. Great, that's all I wanted, 50% of my cake left. You don't have to draw anything. You don't have to make a table, just I have 50% of my cake left. A percentage that's not of a whole, those can be harder to think of. What's an example of using a percent in a sentence that doesn't have the word of right after it?
Are you on?
You
are you
helped
on
me
the-
with this one earlier, so we were going off of weather, like the participation, so like 10% chance of rain. Because there's
Yes,
10%.
participation is a good one. Anything that's a probability. If we say it's a 10% chance of rain, mean that it's going to actually have 10 things happen. In one of them it rains and the other 9 it doesn't. There's no hole out there. It's just a chance it happens. If there's a 5% chance that I get sick in the next month, then that estimate doesn't mean somehow there's a whole bunch of situations and that's my whole, and in one of them I get sick and there's a bunch of copies of me in the time stream that somehow don't get sick or something like that, right? So percentages, we don't have the whole. We can imagine what the whole would be if we roll dice enough or draw cards enough or something, but we don't actually roll dice 100 times just because we're doing a percentage of a dice problem. So a percentage that's not part of a whole is something like it's a 10% chance it will rain today. Okay, number 2, a list of categorical data and a list of quantitative data. So different types of pens I have in my desk, that's categorical data. But how many I have of that is also called categorical data. If you count how many pens of each kind, you're still counting how many are in each category. To be quantitative, we need data where the categories are also numbers. So how much does each of my the number of times I can use each pen before it dries up or something like that. I'm not sure how to do it with pens. But something like test scores, where the numbers on the bottom of your chart, right, your bins, your categories are also numbers. So what's an example of quantitative data from your life? Somebody shout something out.
On quantitative, what I did for mine is I did how many people were in my house, and then so like one person in my house takes a shower 7 days out of the week, and then 3 people in my house take showers 4 days out of the week, and
Oh.
2 people in my house take showers 3 days out of the week.
That makes sense. So the number on the bottom of our bar chart, the categories in our frequency table is how many times a week, and then you count how many people had. Okay, a list of data whose mean and median are very different. So remember that the reason we use median is things like neighborhood home values or salaries in a business where there's a whole lot of change. So if you want to make your mean and median very different, make a kind of dumb data set with a whole lot of zeros or a whole lot of big numbers. So an easy example is, how much do I spend at Costco every day in January? I only went to Costco twice. So 2 days have a big number and all the rest have zeros. So the median for that would be 0, because I'm going to have a list of numbers of which they're all 0 except the last 2. The one in the middle of my ordered list is going to be a 0 because almost all of them are 0. But if I find the mean, I'm going to add them up and divide by how many. And if I spend a lot at Costco, the mean is going to be some positive number. So it is hard to do this with things that have a good sense of an average, a typical. If we like thinking about the average of the situation, it's because the mean and the median agree pretty well. So think of a data set that seems stupid, like how much does it snow every day of the calendar year when it only snows a few days, or something like that, that you wouldn't think to normally make a data set out of. And if you have lots of zeros in it, then the mean and the median will be very different. This person did a good job on number 4. Want the range to be greater than the highest value, then you have to have a negative thing in there somewhere. If I want to say that the price of textbooks, the range of that will be the most expensive one minus the least expensive one, it's going to be some positive number, and it's going to be less than the highest value. But if I have how much somebody, how much money my 4 kids have, and 3 of them have saved up a little money in their piggy bank, but one of them owes me $1 because they bought something at the store, then that -1 will make the range bigger than the highest value. What does it mean if a range doesn't have a mode? I'm sorry, a list of data doesn't have a mode.
That's when a number repeats itself, correct?
Other way around. If there were 2 things tied for most popular, most frequent in your list, they would both be the mode. So not having a mode just means there's nothing that's more common than anything else. All the numbers in my data set are different. Okay, number 5, a list of data with high standard deviation. So something where they're not close to the middle, they're far away from their average value, whatever that might be in real life. The class average on a test where people did about the same would be a good example. A list of data with 0 standard deviation. Yes, there's no change. Everyone gets exactly the same test score. So everyone in my family is exactly 5 feet tall. The standard deviation is 0. We are all the same as our average height. That's not true, but anyway, that's me. For number 6, a data set appropriately written in a frequency table and one that's inappropriate to write in a frequency table. So chances of rolling a 4 on some dice, or the easy way to make it inappropriate is to mix categories. Ask something like, the movies was a good example where genres don't really separate out like that. Ask people to make distinctions that aren't there, and your frequency table doesn't mean much. The other example that wasn't a good frequency table was which blocks are there, what's the average weight of a block. Okay, contingency table. So 2 things being measured, their ages and do they have a cell phone? That's a great contingency table. Something inappropriate to write would be something where they're complementary. If they're one, they're not the other. So then some of your numbers would just be zeros. People who are different ages and people who are still wearing diapers. That's not going to make a good contingency table. And then something drawn as a pie chart appropriately and inappropriate to draw as a pie chart. The easy way to make something inappropriate as a pie chart was the labels of each pie slice are percentages. If you're wondering, what % of the board members of LCC do you have a positive opinion of, then that's going to look really confusing if you draw a pie chart and label all of the pie slices with percentages. Because if 99% of the people think that they are in favor of 75% of the board members, then that's going to be weird. The other classic example is colors. What's your favorite color? Makes a terrible pie chart if you color the slices the wrong way. If you color my favorite color is blue, slice green, then it makes it impossible to read. Complementary outcomes we talked about. They look very nice today as a complement, and complementary outcomes are things like I both win the lottery and I don't win the lottery. One has to be true or the other, not both. And then simple and compound. Simple outcome is one thing from the survey, and compound is the let's combine things. So people 13 or older is a compound of those 2 columns. Whoops, I didn't mean to move it. Whereas a simple outcome is who is age 13 to 14 in this survey. Okay, was that enough of talking about 5B? Let me actually bring back that homework on the screen and not the Word doc. Thank you again to the person that shared that. I wasn't sure if you wanted your name mentioned in the thanks. You can say in the chat, that was me, if you want credit for it. But hopefully going over someone's example was nice.
I found that helpful, so thank you.
You're welcome. Okay, 2 more tasks. A quick overview of the syllabus grading scheme, and then the quiz for today. So syllabus thing, where is that? So there's this chart. And if you are a student that doesn't participate much in class, just does the work, then this is how complicated your Yay, Kristen's getting credit. Okay, good for you. Thank you for sharing. Thank you for being brave and trying that, even though we hadn't talked about some of those terms yet.
It was very difficult. I was struggling.
You tried it too early, right? Before
Yeah.
class. It's supposed to be for after class today, and you tried it before. So, yay, be brave, lead the charge. I hope I didn't use up too much time.
Yeah.
Okay, so the only thing with a percent is your final. I have to tell your future math teachers how well you did on the final. And there'll be a practice final like your practice midterms. There won't be anything surprising. Everything else is just how many things you got done, how many quizzes you made, 9 or more, right? How many homeworks you turned in, how many discussions you participated in with your own thing and 2 replies or whatever it asked. So if you look at that and say that's pretty strict, you are right. There is also the parts here. So the first thing I will add, actually I'm going to make this on a different web page where I can make it not so wide because it will just read better. Okay. Okay, so I'm going to go here. You can not only look up things here, but also there's the list just of your achievements. If you wanted to see those all at once, there is a link there. I'm just going to pick somebody that has done a fair amount of work. So let's look at Gypsy. Has 3 quizzes, 7 homeworks, 1 discussion, and 8 achievements so far. Pick someone out of the blue. Okay. So we're not done with the term. We're only on week 5. How is this student doing in the class? Let's think about this a little. So we haven't done the week 5 quiz yet. They're only missing 1 quiz with 10 weeks. Can this person complete 9 quizzes? Sure, they're ready to earn an A. Hopefully they won't get sick or miss classes or stuff, or if they do, they'll make it up. They've turned in 7 homeworks, and we're not expecting you to have the week 5 homeworks turned in, so you probably have 2 a week for the first 4 weeks, which makes 8. So they're only missing 1 homework. Are they going to turn in all 20 homeworks yet? Not quite. So at this point, then they're in this region. They're going to earn a B because their homeworks are pulling them down. They're way behind in discussions. They've only done 1 of the possible 5 so far. If they do homeworks for week 5, 6, 7, 8, 9, and 10, then they'll be up to 7. So that's going to be their lowest thing so far. But hope is not lost that the achievements lower this. So you get 1/8 per achievement for quizzes. She's done 8 achievements. So it's actually as if she's done 4 quizzes because of her achievements. She's even better here. And then it's also true that, where did it go? Oh, that's right. This was on the other page. So it's not so wide. The 7 colors measure different ways of participating. And let me highlight this. For weekly homeworks is decreased by 2. And the discussion forums is decreased by 1 for each color in which you have 3 or more achievements. So let's imagine, I don't want to actually go look this up, but we could go to a list of all achievements and look up this person's thing and see where their check marks are. Whoops, let's see. Right, and say, oh, they have red, they have 3, green they have 3, and so on. So let's imagine that they have 3 or more achievements in 2 categories. So the weekly homeworks is decreased by 2 for each of these. So that means it's as if they have +4 homeworks. Instead of being in trouble with homeworks, now they're happy. And discussions is increased by 1 for each of these. So now it's like they have +2 discussions because they had 2 category columns. So now they're up here and they're out of trouble. So they need to make up a discussion somehow. Maybe we'll fuss with things at the end and have some makeup opportunity. But that's how this is supposed to work. That to allow you flexibility of how you participate in class, then you have way too many achievements. No one will actually need to do all of these, but do enough that it boosts up your requirements so that you can get the grade you want. Questions on that?
So with the achievements again, do we have to get them done that specific week, or if they were from like week 1 and then we like email you and be like, oh, like I did this like in week 1, blah, blah, blah. How does that work again?
They don't fit any week. They are only listed in the weekly thing because otherwise no one would look at them. +1 quiz. So if I didn't put them in the, let me bring this back here then. And if I didn't put them in this week 5 bit, then you wouldn't look at them because you're only used to looking at week 5. But there's nothing specific to them. If you look at all the achievements, you can do any of them at any time.
Okay, so, okay, thank you.
And if the system is working well, then you should get a fair amount of boost to these overly strict initial requirements by doing nothing at all. You are already, just as a good student, getting 70 or more on one of your midterms because of all the practice tests. You've already, just because you're a good student, done something on the board and need to offer more opportunities for that. You already ask questions during class. You already come to some study session. So these shouldn't be a lot of extra work in your term. Some of them are, because they're kind of interesting and fun, but it shouldn't be a great time sink to do enough of these to make your grade happy. It's also true that this amount here of fussing for discussions, I haven't done discussions before. I really wanted to do them because without being in a class, I thought it would help build community. Are the discussions good things? Are people enjoying the discussions?
I tend to forget about them completely. I don't check Moodle because most of our class is based on our website anyway.
Same.
That's what I was gonna say.
It might be that what we really want to do is take this number, this word 1, and make it say 2, so everyone gets twice as much discussion boost from your achievements or something. I want the discussions to help build community. I don't want anyone to fail the class because they forgot about discussions. That's not the point. So pay attention to the discussions, but I'm not too worried about if you've been forgetting a few weeks. We'll worry about the grades at the end.
Maybe for like next term for you, because you were saying like you wanted some feedback on things. Like I get the idea of doing the discussions to build like a community, but maybe, I mean, I know with your achievements, you make it to where you can earn them, but instead of like discussions, like I know that a few of us have broken into study groups where we're building a community by, you know, meeting out of class time to sit together and work on homework. So maybe instead of doing discussions next term, you can, if you guys want to do study groups and, you know, build your own little community or whatever, that's how they can get to know each other.
Right, we can add something to the syllabus even this term. If you spend at least an hour in a study group each week, then that counts as the discussion if you don't want to do the discussion or something like that. We can
I
fidget.
like that idea.
I like that idea too.
I do too.
So if that is you, then feel free to do that, and the rest of us can play in the discussions. I was hoping it would be awkward to forget just because you have such a nicely formatted to-do list here, and it says discussion forum, and there's a link right there. Right? So I was trying to make it so that it would be like jump out at you, but we'll see. Okay, do we need to do another example gradebook person, or is whoever Gypsy is enough of an example of how this works?
Do one more.
Do one more. Okay, who should we look at? Somebody call out something from the,
You could look at me because I'm curious to see.
okay.
Jules. And a J.
Oops. There you are. Okay, so need to grab that. Need to grab that. Okay, so first of all, just to point out, we don't know how well Jules will do on the final. If she earns between 65 and 70, or between 65 and 69, then she's going to get a D, depending, anything above that doesn't matter. So you have to do well enough on the final to earn your grade. But assuming that she does great on the final, because almost everyone does, the number of people with the amount of practice tests the website makes that actually have their final exam be their limiting factor for their grade is very small. Almost everyone, the final is not your lowest thing. So she has 4 quizzes. If she does this week's one and the ones for weeks 6 through 10, then yes, she's certainly on track for all her quizzes. Homeworks, she's done 7. There's another 14 coming up. Right? She's only missed maybe 1 so far, so she's somewhere in this range. And discussions, she's done only 4. There's 6 more she could do, so yeah, she's on track too, right? So far she's doing A-level stuff. With 10 achievements, then each achievement is an 1/8 of a quiz. So 10 achievements, 10 divided by 8 is 1 greater than 1, I should say. So 1 extra quiz counts towards her thing.
And where'd we pull that 8 from?
A paragraph that said the achievement part lowers the requirement for complete quizzes by 1/8 per achievement.
Okay.
Then we have to look at her colors. She has at least 3 in red. She has 1 in green, 1 in blue. There's another blue. There's a purple. Okay, so only 1 color does she at this point have 3 in. So also 1 color has 3 or more achievements. So that's +2 for the homework and +1 for the discussions. So she's definitely in safe territory so far. And that's again that each color gives you 2 for the homeworks and 1 for the discussions.
And David, you can only achieve 1 achievement once, correct?
Correct. You can't do the multiple.
Can't double dip. Okay.
And then the last part of this was all of that is a plain A, B, or C, or D. If you earn 30 achievements, you get a plus. If you don't get 14, you get a minus. You've been participating too little. So we're halfway through and she has 10. She's definitely going to have 14 by the end at this pace. And she has to pick up the pace a little bit to get 30, but there's also more opportunities later in the term.
I have a question. Sorry, I have a question about the achievements. Hold on, I'm talking. So me and another classmate last night when we were in a study session, we're talking about the playground, and there's a few achievements for the playground. So if we work on that together and come up with a thing, can we turn that one in? Girls, knock it off.
Yes, you can turn in one physical thing, one report, one so on. And the playgrounds, you don't always make a physical product. When it's just share what you did, it might just be that the two of you spend a few minutes on Monday saying, we did the graph theory problem and this is what we liked about it or learned or something.
So I was looking at the play together, work on a playground with someone else. So we don't have to turn that in. We just tell you that we worked on one together.
Right? Just like the fact that if you got more than 70 on the midterm,
Okay.
then just tell me that because I didn't grade it. A lot of these are just tell me you got it done. Okay, we have 3 minutes. Let's randomly roll some quiz problems from last week. We have 4A will be the first 10 out of 20, and 4B will be the last 10. And hopefully I won't roll too many Bs because then I have to make up new data. So a percent decrease. So I'm going to make this a take-home quiz because you can't do a quiz in 4 minutes. That's silly. But I'm going to make something similar to these problems and send it to you by the end of the day. So there'll be something sort of like 7. Remember that 7 was based on 5. You didn't actually have to add up any numbers to find their total annual electrical use. That was just given to you in a previous problem. So you're trying to find a percent decrease with 2 numbers that are given to you. So far, so good. Okay, I'm rolling my die again. 1. Surveys are example of what kind of data? So this one for the quiz, I might ask you to make up an example of this kind of data. Numerical, again, that the categories themselves are numbers. Quantitative is exactly the same thing, a different word for it. Categorical is when the categories are not numbers, they're colors or pets or something. Univariate is when we're measuring one thing. What are your ages? Goes to the multivariate, whereas tell me your major and your age. Or tell me your age and your hobby. Okay, one last problem. The last one of here. No, that one I'm not going to do on the quiz. That one we did already. 6. Excellent choice. Good job, random number generator. So I'm going to give you a frequency table and you have to fill in the relative frequency column. So again, I am going to give you something that looks like that, and you have to add the extra column with the relative frequency to the side of it. Make sense? Okay, I will write that up more carefully and send that out. It is 3:50, our time is done. Run away if you need to. Stick around if you have questions. I'm going to stop the recording.